Hello, my name is Mohammed Qasim Ali, and I am very thankful to you Second International Conference Sustainable Earth Resource Engineering 2020 accepted my paper, and my paper is related to the assessment of water purification quality characteristics, water quality index, and their measurement techniques. I am recently I am a student of University of Malaysia, Pahang. So start of our introduction in our paper. It is a well-known fact that fresh water is necessary for human health. Technology growth and industrial expansion have put freshwater resource in jeopardy all over the world. 1 out of every 6 people on the planet live in a country where freshwater is scarce. It has been noted that developed countries are the most affected by chemical pollution, whereas agriculture resources are associated with emerging countries. Polluted water causes health concern and leads to waterborne infection, which can be prevented by taking action at the household level. Providing safe drinking water is a difficult task for everyone in every country. Contaminants are manufactured byproduct of agriculture and industry, such as heavy metals such as copper, mercury, lead, and chromium, as well as toxic chemicals. Hence, the present study was designed to overcome the issues of drinking water, because water is an essential food item to be consumed globally by everyone. And next, start our material and methods. Study area. Rawalpindi is a densely populated city in Pakistan, located in the country, largest province, and average yearly evaporation of 2,600 millimeter, and a summer temperature also 4.6 degrees centigrade. It is composed of 5 cities, 22 main villages, and 55 small villages. Sample collection. This study was undertaken twice, once in the winter, December, and once in the summer, May, to see if there are seasonal difference in drinking water quality. To study water quality, a total of 100 significant private water purification plants were chosen, which are geographically scattered throughout the study area. In our next step, we analyze the water analysis and determination of pH, TDS, EC, and free chlorine, where the key water quality indicators assessed in this slide. A pH meter was used to monitor the pH and temperature. A portable conductivity used for measure in TDS. A portable calorimeter based on DPD calorimeter was used to measure free chlorine. A turbidity meter is used to measure turbidity expressed in turbidity units, used for turbidity units to express this. Water quality index computing based on through literature analysis. WQI calculation take into account most of the physiochemical features of water parameters, such as pH, TDC, turbidity, and total hardness, anion and cation. Relative weight for each water quality parameters is related to the World Health Organization standard for drinking water. And finally, we discuss about our result and discussions. The water quality at 20 sample station was acceptable for drinking purpose with respect to physicochemical characteristics, but declined total dissolved salt and excess of allied anions and cations. The overall water purification efficacy for reducing total dissolved salt and related anion and cation was greater than 90%. This is the graph about purification efficacy of 30 study of different selected study areas. In manganese is very low quantity, and TDS is very high quantities. So it's good for it. This study is good in TDS. And another graph is related to value of WQO for the collecting groundwater purified. And in this graph, we discuss in 5 different groups for excellent water, good water, pure water, very pure water, and water suitable for drinking, and less quantity of samples that have water suitable, unsuitable for drinking. and more quantity of water that sample have a poor water. Another same like in data collected from the December 15 to 16 that have it's a poor water is also poor water sample is also in low quantity and further discuss about TDS level in groundwater for average 9,906 milligram per liter, but where to reduce 11,932.9 milligram per liter in pure water. According to the water quality index, all filtered water samples were of high drinking quality class 1. Meanwhile, due to large number of dissolved salt, 80.6% of the contaminated groundwater sample was of poor drinking quality class 3 and 10.9% was extremely not good drinking water quality is class 4. Groundwater filtration improves the water quality from extremely. According to the result, groundwater was observed to be significantly declined due to excess of salt. The overall quality of selected sample, meanwhile, 80.6% was of poor quality class 3, 10.9% for very poor quality class 5. Due to higher amount of dissolved salts, it has different approaches for purification of groundwater to convert pure quality to excellent quality water class 1. Thank you. I am very thankful to you for this presentation.